All right, so this week we're going to take a look at the law of sine and law of cosines, two different laws. And the basic idea is we're going to solve triangles. So as I was saying, all the triangles we worked with 2 weeks ago had a right angle, which means you can use Pythagorean theorem. And you could use SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, and all that stuff. Well, if your triangle doesn't have a 90, then you don't have a hypotenuse. Okay, the definition, hypotenuse is always across from the 90. So if there's no hypotenuse, you can't do opposite over hypotenuse, adjacent over hypotenuse. That stuff doesn't work anymore. You also can't use the Pythagorean theorem, because Pythagorean theorem only works on right triangles. So the kind of triangles we're going to look at this week are what we call oblique triangles. So under oblique triangles, there's really two categories you can have. You can have an acute triangle, where all the angles are less than 90. So an example of a specific acute triangle would be like equilateral. All the angles are 60. There's no 90-degree angles. And then an obtuse triangle. That's where you have exactly one angle more than 90. Could you have two angles more than 90? No, why not? Yeah, all the angles have to add to 180. And if you had two angles more than 90, then it would add up to more than 180. So at most, you can only have one angle more than 180. So we're going to look at the diagram that we're always going to draw for solving triangles. When I draw it, it's not always going to be to scale. In fact, probably never to scale. Okay, I just draw it so we know what is across from what. What did we use for the names of the sides? Yeah, you know?
A, B, and C's are hypotenuse.
Yep, last week or 2 weeks ago we used A, B, and C was the longest side. And does anybody remember the name of the angle that was across from A? We used a Greek letter. Alpha. And the Greek letter across from B was beta. So we're still using all those same letters, except we have something new. Okay, what I just circled in red, you never had to label this last week because it was always 90. Okay, so we didn't need a name for it. This week, we need a name for it because it's not 90. So A, B, and C are the sides. A is across from alpha, B is across from beta. And does anybody know the name of that one I circled? Across from C.
Beta.
Well, beta?
Beta.
Beta. So beta is the one that looks kind of like a B at the top. So this one is what you call gamma. Okay, that's a Greek letter, gamma. And it's lowercase gamma.
Do we have to know?
Do you
We
have to?
actually have to know the names of them.
Well, as I'm teaching, I'm going to use the name, so if you don't, you might be confused what I'm talking about. So I'm going to draw things, or if I point to something and I say, what's gamma? You have to know what it kind of looks like. Does that answer your question? Okay. So, 3 sides, 3 angles. Just like last week, I always have to give you 3 pieces of information to start. So I'll give you 3 things, you need to tell me 3 other things. So this abbreviations I'm using, angle, side angle, angle, you might have seen them in geometry, okay, when you did proofs. Okay, we're not doing proofs with them, we're just using that abbreviation to summarize what you are given. Okay, so one of the cases we're going to look at today is if they give you 2 angles and a side in a problem. And there's 2 ways they can do that. Okay, the placement of the letters in the order you write the A's and S's in, that's important. So the first one, this is an example of angle, side, angle. Okay, the reason it's angle, side, angle is because you know 2 angles, and you know the side that's between the 2 angles. Okay, the side that you know connects the 2 angles. It's between them. Versus the picture on the right, you still know 2 angles and a side, but this time the side that you know is not between the 2 angles. You know one of the other sides. Any questions on the difference between being given information that's angle, side, angle, or in this case, side, angle, angle? Not yet. That's good. You also could see it as angle, angle, side. It's the same thing. That one, I don't care if you write it in reverse. If you want to write ASA in reverse, you can go for it. See what happens. We'll talk about angle, side, or side, side, angle in a second. That's going to be our second case. And we'll spend the last part of today and tomorrow on side, side, angle. For that case, I do prefer that you put it in that order. It's a little nicer. And with side, side, angle, you're given two sides and an angle. And the key is the angle that you're given is not between the two sides. Okay? In other words, it's not that. If you were given that, it would be a side, an angle, and a side. That's totally different. We can't do that with what I'm teaching you today. Okay, these are the three problems that you can solve with law of cosines. So for one of these problems in general, the first step is to figure out, should I use law of cosines to solve it, or should I use law of sines to solve it? Okay. These three types are all law of sines. So if you make a reference sheet, it might be handy to list the types that you can do law of sines with, which is what I just showed you. Angle, side, angle, side, side, angle, and yeah, those are the three types. So angle, side, angle, side, angle, angle, side, side, angle. Any one of these three problems, you're going to use law of sines. Okay, there's two other types that we use law of cosines for. Okay, and we'll look at that on Thursday. Okay, so what I just wrote in that chart in blue is exactly what I just wrote there. It's the same thing, just in the chart, it's a little shorter to write that down. Anybody ever done law of sines before? Either at the end of Algebra 2 or pre-cal or in geometry, you might get to it sometimes? Yeah? A little bit? Do you remember it? No. Okay. No? But you're paying attention now. That's good. All right, so let's take a look at what the law of sines is. We'll figure out part of what the formula is. We're not going to figure out the whole thing, but I want to look at part of it. And I'll show you how you use it. All right. So you want to start with a triangle, but you don't need to label everything because we're not going to use every side. I'm just labeling two sides and two angles. And I chose to label the upper left and upper right sides, and then the angles that would be across from them. Okay. After you do that, you put in a vertical line from the top perpendicular to the bottom side.
This is for the law of sines?
Yep, this is for law of sines. Now, does that line that comes down look like it cuts the bottom side in half? No, and it doesn't have to. And I tried to make it look like it doesn't. Okay. This distance from here down to here, what is that? It's the what of the triangle? It's the height. So I'm going to call it h. I don't want to confuse it with hypotenuse, but it's the height. So I'm going to call it h. Okay, and what did I do here by drawing the height in? I took that big triangle and broke it down into two, what? What kind of triangles? Two right triangles. So I took something that was just kind of a big triangle and I split it into two right triangles. Okay? And I'm going to look at the left side and then I'm going to look at the right side separate. Okay? I'm going to start by just focusing on the left side. Okay? So forget about the right side for a second. Okay. I want to think of a trig function that I could use here that would involve this, that, and that. the side that's farthest away from your angle, okay, the one we've called H, is that the opposite, adjacent, or hypotenuse? That's opposite. And what about B? It's across from 90, so that's hypotenuse. So what trig function would involve opposite and hypotenuse? Yeah. Yeah, sines. Has to do with the law we're going to learn. So the sine of your angle equals, what side is opposite? H. And what's the hypotenuse there? B. Now the last thing I want to do on this side is I want to solve it for H. Okay, I'm coming up with a formula to find the height. Multiply both sides by B. Okay, so you get B sine alpha equals the height. So as long as you know this angle and you know B, just take the sine of the angle times B, and that'll give you the height of the triangle. Any questions on that formula? I'm going to do exactly the same thing on the other side. I'm going to block the left-hand side off. Okay, I'll come back to that box in a second. Okay, I want to come up with a formula again to find the height. This time I want to use this, A, and the H. Dave, what trig function would I use here? I'm going to use sine again. And it's opposite over hypotenuse. So what side is opposite beta? And the hypotenuse? A. Okay. And in order to get the height by itself, how would I move A to the other side? It's exactly the same thing I just did on the other side. So now I have a different formula to find the height. A times the sine of beta. Any questions on that? Okay, so I have two formulas for finding the height. We can call it box 1 and box 2. Both of those formulas in each box calculate the same height. So what does that mean about what's in box 1 and what's in box 2? They equal each other, exactly. So B sine alpha is exactly the same as A sine beta. Okay, and that's basically our law of sines. Okay, they just they move something to the other side to make it look a little nicer. How would you move B over to the other side so it's with beta? I would divide by B and D. And how would you move A to the left side so it can be over with alpha? By A. So if you divide each side by AB, on the left side you have sine of alpha over A, and on the right side you have sine of beta over B. And that's how you write the law of sines. Okay, so it starts out sine of alpha over A equals sine of beta over B. And there's a third part. We're not going to go through the proof like I just did. I'm hoping you kind of see a pattern and can guess what the third fraction will be. Anyone think they see a pattern? You can guess that third fraction. Yeah.
Sine of,
What's that new Greek
Gamma.
letter? Gamma over C. That's the law of sines. Sometimes I refer to it as different parts. I consider the first fraction like part 1, the middle fraction is the second part, third fraction is the third part. And you never use all three parts of this at once. Okay? When you're solving for something, you're either going to use the first two parts by themselves, the last two parts just by themselves, or the first part and the last part. But you never use all three parts at the same time. Right, so we proved how to get the first two parts. We didn't prove the last part. We just kind of extended the pattern to find the third one. Okay, so that's the law of sines. Okay, we're going to set up a table just like we did last week. Make a sketch. We're going to put our three sides in one column, three angles in the other column. Just like we did last week. Now we can't use Pythagorean theorem anymore because we don't know if we have a right angle. Most of the time we won't. We have to use this law. That's what we have to use. But there is one other fact we can still use. We said it earlier about the angles in a triangle. What do they all add up to? They all add up to 180. So that is still true. Even if you don't have a right angle, all the angles still have to add up to 180. Okay, so what we'll do with the time we have left, we'll look at one of each of the three cases. Okay? The angle, side, angle, and then side, angle. Okay, so we'll just do three examples. All right, so first thing I'm going to do on this one is I'm going to make a sketch, and I'm going to figure out, is this a problem I should even use law of sines on? Obviously, this one will be because that's all we know right now. But on the test, you're going to have to do that first just to see. Okay. You can sketch your triangle however you want, as long as you keep A across from alpha, B across from beta, C across from gamma. Okay, that's the only thing you have to make sure of. So I'm going to put A, I'm going to put alpha across from it. I'm going to put B, and beta goes across from it. I don't know C, and I don't know gamma. Okay, here's the three pieces of information. Using the three letters, what kind of triangle is this one? Like side, angle, what have they given me? Yeah, you could say side, angle, or you could say angle, side. Same thing. But the point is they've given me two angles and a side, but the side they gave me does not connect the two angles. Okay. If you look at your chart that I just put on the other page, this is one of the three types you should use law of sines for. Okay, so now we know we should use law of sines. Another way you can tell to use law of sines a little bit faster is to just look at your table. If you have a row that has everything in it, then it's a law of sines problem. Okay. Our first row is complete. It has everything in it. So that alone is enough information to tell me to use law of sines. Right, so now our goal is to find B, C, and gamma. Anything I can find there quickly without actually even using what I just showed you for that new law can do something. Yep. Yeah, gamma is going to be 80. Okay, all the angles still have to add up to 180. Now, last week, what did I say about using this angle? Yeah, I said don't use it to find something else, because if you made a mistake with it, you could get something else wrong. And that worked fine when we did right triangles. Okay, with this stuff, you don't need gamma to find B. So if you got gamma wrong, you could still get B right. But you do need gamma to find C. You can't get C without gamma. So what that means is if you get gamma wrong, then C is automatically wrong. There's no way around that. Okay, so some of the problems we do this week, you just have to be careful because you have to use something you find to calculate something else. All right, let's try to do B first. Okay. So we'll find B. And you're always going to set up a proportion. And we're going to use two parts of this law. I definitely want to use the part of the law that has A and alpha, because I know both of them. So I'm going to look back at the law, and I'm supposed to do sine of alpha divided by A. And I'm going to put that on the left-hand side. So sine of 40.
Is the other side of the room?
No. Divide by 4. Now, depending on if I want to find B or C, I'm either going to use the second part if I want B, or the third part if I want C. I'm doing B. So I'm going to use sine of beta over B. You don't need the third part in this for right now. Okay, so now let's go back to the problem. Sine of beta is 60 over B. Whenever you set up a proportion with law of sines, you should have numbers in 3 of the spots. 4, 40, 60. You should only have a letter in 1 spot. If you end up with a letter in more than 1 spot, chances are you should have used law of cosines. So stop, because you can't solve it if there's 2 letters. Okay, and what's the technique when you want to solve a proportion? What do you do? Yep. Yep, you cross multiply. So we get 4 sine 60. I don't care what that is right now. I'll type it in at the end. Equals B times the sine of 40. Okay, and my last step is to get sine of 40 on the other side, so B is by itself. All right, so Gabe, how would I finish that off to get B by itself?
Divide side.
Yep. Divide side by sine of 40. And now just type that in. That's B. Okay, if I type it in, what do I want to be careful about? Because if I type it in on my calculator right now, it would come out wrong. I'm in radians. Okay, whatever calculator you have, just make sure you put it in degrees. We'll be doing degrees all week. Okay, so always in degrees for these problems. Okay, 4 sine 60. And what do I have to do on my calculator? Because it did something. I didn't press the button. It just did this automatically. Yeah, it put a parenthesis in, so I have to close it. Okay, if you want to type anything after the 60, you need to close it. And I do want to type something after the 60. I want to divide by sine 40. You can try not closing it. Okay, watch what happens. You won't get 5.389. You get something different. All right, so B is 5.389. So we have all the angles. We have 2 out of 3 of the sides. Could I do Pythagorean theorem now that I have A and B? No, why not?
Because you just found out that you said could be wrong.
Okay, it could be wrong, but it's also not a right triangle. So if you don't have a right triangle, A squared plus B squared does not equal C squared. It doesn't work. Okay, so we'll find C exactly the same way we just found B. Okay, you're going to set up a proportion. Okay, this time I have 2 rows that are complete. I could use the first row or the second row. Which row should I use? Which one? Why would you use the second over the first?
Because they're next to each other.
Well, well, you mean like they're next to each other? Like,
Yeah. Like it goes in later.
all right. Anybody have a thought about why the second row, if I can stay away from it, I kind of want to for a couple of reasons. You could use it, and it could come out right, but I want you to answer my question, and I'll explain why it might not come out right.
You just found B.
Yep.
So you should kind of use it.
Yeah, we found B, so if B is wrong and we use it, then C is wrong, guaranteed. So I said we can't avoid using gamma, you're going to have to, but you can avoid using B. So we're going to use the row that they gave us, and even if B is right, I don't really want to work with a decimal. It's going to be less work to type in the number 4 than 5.389. So we're going to start with sine of 40 over 4, just like we did before. And anyone think they can tell me what's going to go on the other side? What's going to go on the other side of that?
Sorry. Sine of 80 over C.
Yep, sine of 80 over C. Now, you don't have to show me the cross multiply step like I did right here. If you just want to jump to the final answer, that's fine. When you cross multiply, it's going to be 4 sine 80. Then you would have to divide by sine 40 to get C by itself. It's exactly what we did in the last problem. We had to divide by the sine 40. It's the same thing, just a different angle right there. Okay, so you cross multiply, solve for C, and that's your answer for C. Okay, so on your calculator, sometimes it's easy if you can just pull up the last thing you typed in and just change the one thing you need to change. So it's 4 sine 80 over sine 40. If you can't, then you just have to type the whole thing in again. All right, so we get 6.128. Okay, I gave you a suggestion last week how you can look at that kind of quick and see if something is obviously wrong. What should always happen with sides and angles in a triangle? Do you know? Okay, the angle should add up to 180, so double check that. Make sure they all add up to 180. What else? Yeah, Josh?
Adding two sides should be larger than the one side.
Yep, anytime you add two sides together, it should always be bigger than the third, which that works here. 4 and 5 is bigger than 6. 5 and 6 is bigger than 4. And 4 and 6 is bigger than 5. So if you add any two sides together, they're bigger than the third. And the biggest angle should always be with the biggest side. The smallest angle with the smallest side. If that's not true, then something's wrong. Okay, so any question on the angle side case?
Does it matter if you say side angle?
No.
Okay.
Nope, as long as you know these two things are the same. Yep. Okay, second case. You're still given the same information, but you're given in different spots. This time you're given an angle, a side, and an angle. We know the side that's between the two angles. So this one is angle, side, angle. Any questions on why it's angle, side, angle? Okay. Is angle, side, angle one of the three types that we should use law of sines on?
Yeah.
Yes. Okay. What's another way I said you could tell to use law of sines? Just by looking at the table. Okay. If you have a row that's complete. Now, with what they gave me, do I have a row that's complete right now? No. I do not have a row that has everything in it. But could I easily figure something out that would give me a complete row?
Yeah.
Yes. What could I figure out? Yeah, I could find gamma. 45 and 40 is 85. And then subtract that from 180. And you get 95. Now, this one, it's even more important we get this angle right than it was last time. Why do you think it's really important we get 95 right? We're going to use this row to find A, and we're going to use that row to find B, because it's the only row with everything in it. So if you get gamma wrong on this one, then A and B both come out wrong. So just be careful. I mean, simple, just use your calculator if you want to double check it. Make sure those all add up to 180. Okay, as far as the order, you can find A or B first. Doesn't matter. Right, so, James, what do you want to do? You want to do A or B first?
A.
A. Okay, we're going to find A. Set up your proportion. And the row that I checked off in blue, we're going to use that. You can put it on the left or you can put it on the right. It doesn't matter. It'll come out the same. So Marcos, if I put it on the left, what would go on top?
Sine alpha.
Okay, so we can set that side up first, sure. Sine of alpha, but what is alpha? 45. And what would go in the bottom? A. Now we put our letter. Since he put the letter here, everything else we put has to be numbers. Okay, no more letters. So Michael, what would go on top on the right-hand side?
Sine 95 over 4.
Yep, sine 95 over 4. Perfect. Okay, so when I cross multiply, Kristen, could you tell me what I get when I cross multiply the final answer for A? It'll be what times what, and then divided by what?
4 sine 45
Yep.
equals 8 sine 95.
Okay, so 4 sine 45, and then when you get A by itself, what will you divide by?
Sine 95.
Sine 95. Any questions on the cross multiplying or then dividing to get A by itself? If you want to show the cross multiply step out, that's fine. Now just type that in and see what we get. Okay, so we got 4 sine 45 divided by sine 95. Do I need a parenthesis after the 95? No, because I don't plan on typing anything else in after it. If I was going to, then I would. Okay, so 2.839. Since beta is a little bit smaller than alpha, bless you, B is going to be a little smaller than A. All right, so last step, we need to find B. Find B. Okay, how about Devin? What row am I going to use to find B? I'm going to use 2 rows, but what's one row that I'm going to use?
Sine B, beta over B.
Yep, we're definitely going to, so we're going to use the second row, because that has the thing I want to find in it.
And then C.
Yep. So we're going to do sine beta over B, and then we're going to use the third one, because it's the only row with everything in it, and the numbers are nice. So don't use row A. Excuse me. Even if the numbers are nice. Even if the number is right, the number, it's a decimal. Okay, so we're going to stay away from row A. So on this side, I'm going to put sine 95 over 4. Okay. Questions on setting up the proportion? Okay, now we solve it. Okay, so when I cross multiply and then solve it, yeah, Bryce, what do I get?
4 sine 40 over sine 95.
Yep. You get 4 sine 40 divided by sine 95. Okay, so just type that in, and then that's our answer for B. So I get 2.581, which is a little bit smaller than the number I just found for A, and that's what I expected. Okay. Looking quickly, it looks like if I add any 2 sides together, they're going to be bigger than the third. Biggest angle, biggest side, smallest angle is with the smallest side. Looks good. Why didn't I do Pythagorean theorem with A and C to get B? Yeah? It's not a right triangle. Okay? If you happen to get a problem on the test that is a right triangle, you can still use everything I'm showing you right now, or you could go back and do it the way you learned 2 weeks ago. You could do it either way. I think this way is a little bit harder if you have a right triangle. It's shorter to use Pythagorean theorem and SOHCAHTOA. But this will still work. Okay. Questions on the angle side angle? Very, very similar to the first one. Almost no difference at all. Okay, and the third type. So I'm going to put this information in the table the way you're used to seeing it in a second, but I'm just writing it like that for now. Okay, and I drew the diagram for you. Okay, this one, you know a side, you know another side, and you know an angle, but it's not the angle between the two sides. That's gamma. We don't know gamma. Okay, so this one is side angle. Okay, so what's a little bit tricky about side angle, and this is the only case out of all 5 we're going to look at. Okay, I showed you 3 today. We're going to look more at this one again tomorrow, so we're going to do that again. And then you're going to learn 2 more on Thursday. Side angle is the only case where 3 different things could happen. First thing that could happen is you go to solve it, and it's just like a normal problem. Just like the ones we've been doing. You get one solution. Okay. The other thing that can happen is you go to solve it, and you get 2 solutions. Okay. When you have a problem that's 2 solutions, it's not harder, it's longer. You have to do everything twice. But it's the exact same calculations, just with a different number to do it all twice. And the third thing that can happen is no solution. No solution is generally the fastest one because you go to type it in and you realize right away you can't find anything. Okay. No solution would be like a problem that if you tried to draw it out, it might look something like this. One side might be too short to actually connect and make a triangle, or it could be too long, something like that. Okay. But the point is, a no solution would be an impossible triangle to draw based on what I gave you. Okay, so we're going to try to solve this one and see what happens. If it's 1 solution, 2 solution, or no solution. Okay, so now I've set it up like you're used to seeing in the table. I've got my 3 sides, my 3 angles. Okay, and even if I didn't have a picture here, what's the trick to look at the table and figure out this is law of sines? We have a row with everything in it. So the fact that I have a row with everything in it tells me that it's law of sines. And also the fact that I have a row with nothing in it, and I have no possible way of finding anything in that row, tells me it's the side angle case. If you go back and look at the other 2, we never had an empty row, ever. Okay. In this problem, you were given something in every row. There was no row that was empty. And in this one, we had a row that was empty, but we could find something in it easily because the angles all added up to 180. Okay. I can't use the trick that all the angles add up to 180 here because I'm missing both angles. So I have no way to find gamma. I can't use Pythagorean theorem to find C because that would assume that it's a right angle, and I don't know that. So I can't get C or gamma. So that means, what do I have to find first? No, we can't get C or gamma. We have to find, what is it? Beta. So this is the first time we've ever had a problem where you have to find something first. Okay, you have to get beta first. You have no other choice. So I'm going to use row 1 and row 2. And we're going to find beta. Okay, what can I put on the left-hand side? Sine of what over what? Do you know?
40 over 3.
Yep. Sine 40 over 3. We haven't written a letter yet. That means the letter's going to have to come on the other side. Okay. What's going to go on the other side? Devin?
Sine of beta over 2.
Sine of beta over 2. Hey, did anybody see what's a little different about that proportion compared to the last two problems? Something different. And the thing that's different has to do with why you could get one solution, two solutions, or no solutions.
The unknown variable is on the side.
Yeah, the variable is inside the sine function. It's not in the bottom of the fraction. Okay, so we still start to solve it just like we would. We're going to use something in a second that we've done before. So we get 3 sine beta equals 2 sine 40. Start with that. And I can at least get the 3 on the other side. And how could I move the 3 over? Yep. I can divide each side by 3. And now I'm left with sine beta equals 2 sine 40 over 3. But I don't want to know the sine of beta. I want beta. So how do I get rid of the sine function? And we've done this before. Yeah, we take the inverse sine. Take the inverse sine of what's on the left. Those are going to cancel. And do the same thing on the right. You can't cancel anything on the right. You have to type it in exactly the way you see it right there. And I'm going to type that in. Okay. Once I type that in, if this is a no solution problem, the calculator will give me an error. Okay. Otherwise, if the calculator gives me a number, then I'm guaranteed that there's at least one solution. So let's type that in. So inverse sine of 2 sine 40. Okay, and divide by 3. Okay, and I get 25.374. So this is not a no solution. If it was, I would have just gotten an error, and I didn't. I'm going to show you how you get the second answer. Well, what I do on this kind of problem is I write the number a little bit higher in the box. So if there is a second answer, I'll put it below it. But we don't know yet if there's a second answer. Okay. So to check if there is a second answer, take the answer that we just got. In our particular case, we were solving for beta. You might be solving for something different. But take whatever you just solved for and subtract it from 180. Okay? So let me do that. I got 25.374. I'm going to subtract 25.374 from 180. If there's a second answer, that's what it is. It's 154.626. I didn't say that was the second answer. I'm saying if there's a second answer. It's 154.626. So I'm just going to write that there for a second. And if it works, I'm going to go put it up in the box. If it doesn't work, I'm going to cross it out, forget about it, and continue solving this problem just like normal.
That wouldn't work though.
How come it wouldn't work? Before I explain how you check.
We already have a 40 degrees up there, 40 and 154 and 190.
Right. All you have to do is check with the angle that they gave you and see if your second answer would fit. 154 is too big. Okay? And that's basically what I have written right here. See if it's possible to take that angle you just got, which was about 154, and the given angle, which in this particular problem was 40, see if they would fit in the same triangle. They don't. This would add up to 194. The second answer is too big. In this problem, the second answer doesn't work. And I think that's exactly what I explained right here. So if there's another answer, it's 154.626, but you were given a 40-degree angle to start. If you add those two together, it's greater than 180. So you don't have to write that down if you understand how we determined it didn't work. So any question on how we got the 154 or how we determined that it doesn't work in this problem? Okay, so those are your first two steps. Find the angle, then determine if the angle works. So I'm going to cross it out because I don't need it.
So that could, there would be two answers for any one of those.
If the answer had worked, then there would have been two answers in every box. Two answers for beta, I would have put 154. Two answers for gamma, two answers for C. If the second answer doesn't work, you don't have to worry about a second answer for anything. There's only going to be one answer for gamma and one answer for C. And now that I know beta and I know alpha, how can I get gamma? Yeah, add them together, I get 65.374, and then subtract from 180. So minus 65.374. It's 114.626. Now I finally have a piece of information in the last row which I can use to find C. So my last step, set up your proportion to find C, and this is going to be just like we did in the first two. Which row should I use? I could use row A or row B. Yeah, I'm going to use row A. Sine of 40 divided by 3 equals sine of 114 divided by C. Cross multiply and solve for C just like we did in the first two problems. Are you going to need inverse sine again?
No.
No, you only need inverse sine if the letter is next to sine. This time the letter is in the bottom, just like the first two examples. And then just solve that. Okay, so tomorrow we'll spend some more time looking at this case. We'll review one where there's one solution, and then we'll do a no solution and a two solution. And that'll finish law of science. Okay, so homework, it's in your book on 266. It's all odds. 9 to 13, 17 to 21, and 25. Okay, just the odds.